So this is Luke Nelson and Ethan Elmer's math project on the Pythagorean theorem and the converse of the Pythagorean theorem. The Pythagorean theorem was discovered or created by a man whose the name of the theorem is pretty close to Pythagoras. He lived in the Renaissance period of time. He figured out that of a right triangle, a squared plus b squared equals c squared. So let's make a triangle here. Marker's running out. All right, that's really bad. So it's got to be on the opposite side of the square is c. So this, let's just say this is b, this is a. So Pythagoras figured out that these two added together would equal this right here. So let's start off with this is our equation, equals c squared. So let's say a is 8, so 8, and then plus b, which is, I don't know, that doesn't really make any sense, but we're just gonna go with it, 10, and gotta be 10 squared. So let's start off, and then this will equal c, which we don't know what it is yet. So a squared equals 64, and then you got to plus 100, because 10 squared equals 100. So those two added together equals 164. And then this is where it gets a little tricky. You have to do 164, square root it, because you got to get c by itself, which if you square root c squared, it equals c. So square root of 164 is 12.81. So this is your answer for length C. Alright, now let's talk about why this is really how it is, how Pythagoras thought of taking these two and adding them together. So let's take a normal triangle, and so he thought, here's a square, so he thought this right here, B, this right here, A, would equal up to C. So these two added would equal C. So let's see here. So that would, in order to get, you'd have to do a squared because it, and b squared because c has to be bigger than both of these no matter what. If it's not bigger, it's wrong, and I'll show you a problem that's like that. So there you go. And anyway, so going back to the other problem, 64 plus 100 is these two added together, therefore it would equal this, but as I explained, you'd have to square root to get c by itself. And so it's the same thing, just you gotta add both of these up. But now let's see if we can figure out what length A or B is. So let's start all over, and we'll say this is our triangle. Let's say we know C, right? And that equals 27. Okay, and then A equals 16. So 16 squared, 27 squared, A equals, and we don't know B yet. So here's how you set it up. 16 squared plus B, because we don't know it, squared, equals 27 squared. So 16 squared equals 256. Now you would have to subtract because you have to subtract and then square root to get b by itself. And then you have to subtract because these two are, this is the answer for C, and then this is the what you have to add. So in order to figure out what you have to add to this, you have to subtract. Alright, so let's do 27 squared is 729. So 729 minus 256 is 473, and you have to square root it. Same with square rooting b squared, and that equals 27 23.7, which is slightly bigger than 27 squared, which is C. So this is not a right triangle, so to speak, because it does not work, but that is just one way to figure out, and it's the same exact way for A. You just have to subtract and then get that. So the converse is pretty much if those two, if we had the lengths of every side, so let's say 15 squared plus 18 squared equals 20 squared. Now we have to see if these two equal 20 squared. So 225 plus 354, which is these two squared, equals 549. So 549 squared and C2 squared, or yeah, to get it by itself, and that is 23.43, and that would be C, but 23.3 is not the same as 20, therefore it is not a right triangle. Alright, thank you for watching. This is Ethan, Elmer, and Luke Nelson's math project video.